Hello, this video is going to cover descriptive statistics, where we're going to talk about bar graphs, histograms, and pie charts. Okay, descriptive statistics. So far we've worked with frequency and relative frequency tables, but in this chapter, we're also going to visually summarize the data. More than just using a table, we're going to create graphs such as bar graphs, histogram, which is another type of bar graph, and pie graphs, etc. So in addition, we're going to learn to measure four things: where data points fall, where they're centered, whether they're skewed or symmetric, and then how spread out they are. Now, these four things we're actually going to learn later in chapter 2 when we go into the material for the next test. All right, so this is an example of a bar graph. Bar graph summarizes the data that we have from a frequency table that deals with qualitative data. So this bar graph, you'll see, is the number of women who work, it looks like, different types of occupations. So domestic service, transport and communication, agriculture, persons without specified occupations, and unknown occupations. And so what you'll see here is each one of these categories has a bar. Each of the bars are the same width. Now this was made using, this bar graph was made using spreadsheet software. I'm not sure if it was Excel or Google Sheets, but it was made using one of them. Now, again, this is qualitative data, so let's look at some characteristics. The bar graphs usually display qualitative data. They usually don't touch. Look how the bars, they don't touch. Okay. Bars can be vertical, like we have them here, but you may also see them horizontal. Okay. Bars are equal width, so I've already shown you that. There's one bar for each category. And the height, it will either represent the frequency or the relative frequency. So it looks like it represents the, in this case, it represents frequency, because relative frequency would be decimal numbers between 0 and 1. Okay, so this graph, what it's missing is it's missing labels. So occupation would be here. And then over here we would say frequency. So you want to make sure when you make these that you label them. You can, for this class, you can draw them out, but you're also welcome to use software. Not software. You can use spreadsheet software to create them if you want. All right, so there's another kind of bar type graph, but it's not called a bar graph, it's called a histogram. So this is what we use to display quantitative data. So the bar graphs here displayed qualitative data, and then here we're going to do quantitative data. And histogram bars are always vertical, whereas bar graphs can be horizontal or vertical. Notice the other thing here is that the bars touch. So that illustrates that there are no gaps. The horizontal axis shows the classes, and then the vertical axis shows the frequency or the relative frequency. All right, so construct a frequency bar graph and relative frequency bar graph for the computer cell. So I'm just going to show you what this looks like. So first, this was frequency and a relative frequency distribution. We've got types of computers sold: desktop, laptop, notebook, tablet. The frequencies are 11 desktops, 23 laptops, 9 notebooks, and 7 tablets. So you can actually make two graphs from this. You can make a frequency bar graph, and you can make a relative frequency bar graph. So let's look at those. So they look the same. They look almost identical with heights and all of that. So if you'll look, this is the frequency bar graph. So we've got desktop, which goes up to 11. Laptop goes up to 23. notebook up to 9, and tablet up to 7. So some other things to notice here. We do have the categories on the bottom, frequency on the left. Notice we don't have the numbers 11, 23, 9, and 7 listed, even though we're doing the frequencies. What you want to do for your frequency is you want to start at 0 or a number below the lowest frequency. Okay, it doesn't necessarily have to start at 0. So 0, and then you want to count by common intervals. So it looks like we counted by 5 here. So 5, 10, 15, 20, 25. All right, so you want to make sure that you do it that way. You don't have to count by 5s. Again, you can figure out how you want to count and just make sure you're consistent. Now, look, this one is a relative frequency bar graph. So again, we have the categories on the bottom, and on the left, on the vertical axis, we have the relative frequencies. Now, again, the relative frequencies were 0.22, 0.46, 0.18, 0.14. We didn't necessarily write those numbers down, but we made sure that there was a place where they could fall. So we went from 0 up to 0.5 because the highest relative frequency was 0.46. So you wanted to go above that, so, or at least to 0.46. So it looks like we counted by 0.10. So 0.10, 0.20, 0.30, 0.40, 0.50. Just want to make sure you're aware that 0.04 is the same. I'm sorry, I'm writing this wrong. 0.4 is the same as 0.40. All right. So anyway, 0.46 would fall somewhere between 0.40 and 0.50. And so if you look, that's the case here. Desktop is 0.22, so that falls close to 0.20, but between 0.20 and 0.30. Notebook is 0.18, so that falls between 0.1 and 0.2, but closer to 0.2. And 0.14 for tablet, so that falls between 0.1 and 0.2. Right, so that's a bar graph for you. All right, so a city is broken down into 6 districts. The table shows the percentage of total registered voters population. I'm sorry, I'm going to start over and read this again. A city is broken down into 6 districts. The table shows the percent of the total registered voter population that lives in each district, as well as the percent total of each entire population that lives in each district. The bar graph shows the registered voter population by district. So, registered voter population, district. Now, whereas this looks like it is quantitative data, technically it's the name of the, the number of the districts. So it's kind of like the qualitative. There's only 6 districts, so you can definitely organize it that way. So District 1 was 15.5, District 2, 12.2. District 3, 9.8. Notice they're given these numbers, these relative frequencies, as a percentage, which you should be able to go back and forth between the two. As a percentage, this is 15.5 for District 1, but a decimal form, it would be 0.155. The way to go back and forth is to change a percent to a decimal, divide by 100, and to go the opposite direction, multiply by 100. Anyway, so here these are graph, another bar graph. So what I want you guys to do is I want you to make another bar graph, but for the overall city population. So you'll have the districts at the bottom, but on the left you'll do the overall city population instead. And then when you unpause it, we will we'll come back and go over it together. All right, so here we go. I'm gonna create this. On the bottom we have city district, and then on the side we have percent I'm sorry, that's wrong. That is not correct. Yeah, it is percent of, so I'm just going to write it up here, percent. Actually, I'm going to type it out because that'll be quicker. Percents of total city population. And then it looks like the highest one is 19.4. So I want to go up to at least 20%. It's up to you how you want to count. I'm going to count by 5%, 10, 15, 20. So we got the percent over here. And so we got District 1, 2, 3, 4, 5, 6. All right, so 1 goes up to close to 20. So that one goes to 19.4. You don't have to do this, but sometimes people will label at the top for readability purposes. 15.6 for 2. And then 3 goes up to 9, so just below the 10. And then you try to make them the same width if you can. Mine's not perfect because I'm drawing it by hand. 4 goes up to 18, 18.5. It looks like, oops. Oh, I did it again. I'm erasing my lines by accident. I wanted to space out that 5 and 6. Okay, 5 goes up to, oh, you know what? I should go up a little bit, 25%, because the highest here was 20.7. So my bad. So 20.7. And then last is 6, which goes to 16.8. So you can see mine, I'm not, I need a ruler. But basically they look like that. And sometimes people will do different colors. Color the bars, different colors. A lot of times when you do this on Excel, you can have a different color for each bar. It also lets you add texture and a dimension as well, which is kind of cool. Sorry, it's taking me a moment to do this. But I've started now, I don't want to stop. I can't not have them all a different color. Yeah, anyway, they should be the same width apart, the same width for each bar, and mine isn't exactly like that because I free-handed it. But if you were doing this in a study, you'd probably use, like I said, spreadsheet software or some kind of software to help you make very neat graphs. If you're doing this for a project and you do it by hand, try to use a straight edge or something so that it is a little neater than mine, but it's the basic gist of it. Okay, so other kinds of bar graphs, you've got side-by-side graphs here. So if you look, Facebook, Google, YouTube, MSN, Yahoo, this is the frequency of visits of to popular websites. So from showing you the difference between 2009 and 2010. So you can see Facebook from 2009 to 2010 really took off. Yahoo kind of stayed the same. MSN only slightly went up. But it's a way to compare. Now, another type of table that is really important that people often forget to study is a Pareto chart. So make sure you study this. So sometimes it's desirable to construct a bar graph in which the categories are presented in order of frequency, with the largest frequency on the left and the smallest frequency on the right. So look at these bars. They go from highest to lowest. So they reordered. This is the same graph from this here. So here with a desktop, laptop, notebook, tablet, this particular one right there, all they did is they rearranged it so that the categories went from highest to lowest in regards to relative frequency. So if you're asked to do a Pareto chart, it means rearrange the categories so that the bars go from highest to lowest. Then you have your pie chart, which I'm sure you've seen before. It's an alternative to a bar graph for displaying relative frequency. So you usually do percentages for pie charts. A pie chart is a circle and it's divided into sectors, one for each category. So the relative sizes of the sectors match the relative frequencies for the categories. For example, if a category has a relative frequency of 0.25, then its sector takes up 0.25% of the circle. So this would be an example. Now you don't have to worry about trying to figure out the sizes or creating one of these, but you will have to be able to read it and answer questions about a circle graph. So you can see we have the same data here with a desktop, laptop, notebook, and tablet, but instead of making it a bar graph, the desktop is 22%. The laptop is 46, which is almost half, almost 50%. So you can see that corresponds with the number. It's a bigger slice of the pie here. Notebook is 18, and the smallest is tablet, which is 0.14. So the size definitely corresponds of the sector definitely corresponds with the frequency, the relative frequency. All right, so we're going to talk again about histograms. So we mentioned them earlier, what they were. They represent quantitative data. Each rectangle has a height of the frequency or the relative frequency similar to a bar graph. The width of each rectangle is equal to the class width, and the bars have to touch. Don't forget that part. The bars touch. So let's look at this on creating a histogram. So first you're going to do your frequency or relative frequency distribution. You're going to create your classes like we did in the last section. Okay, and then below here I have both the frequency and the relative frequency histogram, both here for you to view. And so check this out. So when you do these with the class width, okay, instead of saying, now sometimes people will write below each bar 0 to 0.99, but you can see that takes up a lot of space. So sometimes it's easier to do it this way. So what they do is they have the lowest lower limit at the left of each bar. So they only put the lower limits rather than the lower and the upper. Again, you can, I have seen them where they make the bars and then you put 0 to 0.99, and then this bar, oops, and then this next bar would be 1 to 1.99. It's harder for me to write on a screen really small with the stylus that I have, but you could do it that way. It's just, sometimes it's hard to make it fit. So instead we just do the lowest lower limit on the left side of each graph. So what that means is that when you're looking here, this goes from 0 not to 1. The 1 is the lower limit of this bar here. So this bar goes from 0 to 0.9 or 0 to 0.99. This bar goes from 1 to 1.99. This bar goes from 2 to 2.99. This one goes from 3 to 3.99, so on and so forth. And then the heights represent the frequencies, or in this case over here, the relative frequencies. Now, how many classes should you have? Now, you usually decide that when you're doing the relative or the relative distribution or the frequency distribution before you even get to the graph part. But I just want to show you here that if you have too many classes, look what it looks like. It's just too many. Now, yeah, there's some space, but that's because these are categories, or these are classes that have 0 as a frequency. That's why there's no bar there. Anyway, it's too jagged. It's very distracting. It's hard to read. Whereas over here, too few classes don't tell you enough. It looks very basic. So I think I had said when we talked about frequency distributions that above 3 but less than 10 is good. So this one has 4, and I think it's okay, but I wouldn't go any less than that. Now, you can have open-ended classes for your frequency distributions, but when you, like this is age, starts at 5, goes all the way up to 75 to 84, and then 85 and older, right? So that's considered open-ended. This is okay for a frequency distribution or a relative frequency distribution, but you cannot translate it into a histogram because you can't have an open-ended bar. So no histograms for open-ended data. All right, so discrete data, when you have a small enough range that you don't need classes, you can just put the numbers. In that case, you put the numbers in the middle of the bar underneath. Instead of doing a lowest lower limit on the left, since there's only one number, not 2, you put it underneath in the middle. All right, so we're going to look at example 2 and example 3, and we are going to do these. So I'm going to do example 2 with you, and then you guys can do example 3. So this one says, recall the following data on the number of iPads sold between 0 and 5 on the last 50 days. So it says create a frequency histogram for this data. So this is not my favorite because we're missing some numbers. So we have 0, we have 1, 2, 3, 4, 5, and then 6. Okay, so 0, so these aren't classes, so I'm not going to do 0 to 1, 1 to 2, or anything like that. I'm just going to make the bar right above each of the numbers. So 0 goes up to 5. And let me try that again. 0 goes up to 5. And then 1 goes up to 8. And then 2 goes up to 14. So it's not quite to 15. Let me try that one again. All right, and then 3 goes up to 13. And then 4 goes up to 6. And then 5 goes up to 4. And then there's no 6. So, and again, if you want, you can do colors if you want. There's my colors to make it look nice. Anyway, so also make sure that you label each piece. So down here you would say this would be number of iPads sold. All right, so here we go. We're going to do one with the class. So I'll just show you, I'll just do this first one with you, 0 to 2.9. So this is 0, it looks like it's 0 to 3, but it's not. It's 0 to 2.9 because the next bar starts at 3. So 0 to 2.9 goes up to 0.10. So pause the video, and then when you come back, we'll go over what it looks like. All right, if you've unpaused it, hopefully that means you've completed the graph. So the next one goes up to 0.36. And then the next one goes up to 0.18. And then we have 0.22 and 0.12. And then 0.02, so that one's really small. And I think that's it. So just do different colors to help you differentiate between the bars real quick. That bar looks a little wonky. But you can see we've labeled the bottom here, and then here you would say relative frequency. All right, so that's really all for this section. We're going to continue talking about descriptive data as we move forward into the rest of chapter 2. We're going to talk about the shape of histograms and what that means, and then we're going to calculate some other things like mean and median and mode, and some things you may not have calculated before in the past, but we're going to do that as we move on to later in the chapter. But just remember that your first test will cover chapter 1 up through this section in chapter 2. Okay, so if you have questions, remember, post them on the homework help wall, email me, or attend my office hours. All right, thanks.